Best fit straight line. So when we do a scatter diagram between two numerical variables, and we can see from the scatter diagram there exists a pattern, a systematic pattern between the two variables. So if the dots or the data is showing a linear relationship, whether it's a positive relationship or negative relationship, we can prove this by drawing the best fit line through the data. So when we draw a best fit line, which is a straight line, it is the best because it represents the data on the scatter diagram. So this line may pass through some of the points or none of the points or all of the points. So if it is past all of the points, meaning the point itself is becoming a straight line. So the closer the data points to the straight line, the higher the correlation between the two variables or the stronger the relationship. So how to produce this straight line? Regression analysis. So in regression analysis, we generate the best fit mathematical equation to analyze the relationship between dependent variable and also independent variables. So previously what we did, we just used variables. One variable, the first variable, and also the second variable. Now we are defining dependent variable and also independent variable. So dependent variable, usually we denote by the letter y, is a variable that is being estimated or predicted. Independent variable, usually we denote by the letter x, is a variable that is related to dependent variable which provides the basis for estimation or prediction. Mathematical equations that describe relationship between the dependent variable and also independent variable, we call it as models. So we have two types of models, deterministic model and also probabilistic model. So in deterministic model, it is an equation that allows us to determine the value of y from the values of x. Meaning that once we get the value of x, we can always know what is y. So this type of models are usually unrealistic. The second type is the probabilistic model, whereby it is a method used to capture the randomness that is part of a real life process. And to create this probabilistic model, we need to start with the deterministic model and add an error variable that measures the error of the deterministic component. Let's look into simple linear regression model to further understand the concept. So simple regression analysis indicates the value of a dependent variable, which is y, is estimated on the basis of one independent variable, which is the x. So you have two variables, one is y, one is x, and this is called simple linear regression model. If you have one variable, dependent variable y, but then more than one independent variable x, suppose you have two or three independent variables, then it is called multiple linear regression model. So in simple linear regression model, you have y as a function of x. So we want to estimate y based on x. So here, since we are using linear function, the simplest function that we can use, it is y equals to beta naught plus beta 1x plus epsilon. And then to define this, beta naught is the y-intercept, beta 1 is the slope coefficient, and also the epsilon is the error variable or error terms or disturbance term. So if you look at this linear model here, so this is resembles what we learn in mathematics, whereby this is simply the intersection with y-axis, and this is the slope of the line, which is here we call it as the slope coefficient. So this is a straight line with y-intercept and also value of slope, and we have an error variable here. If this model is written as y equals to beta naught plus beta 1x without the epsilon, so this is the deterministic model. Y equals to beta naught plus beta 1x is the deterministic model. But once you add on a random variable here, which is the error variable here, then it becomes a probabilistic model. Multiple linear regression model indicates, the value of the dependent variable is estimated on the basis of two or more independent variables. So in terms of the model, we can write it as y equals to beta naught plus beta 1 x1 plus beta 2 x2 until beta k xk and plus epsilon. So if you write y until beta k xk without the error variable, this is the deterministic part. So once you add the error variable, it becomes the probabilistic model. In the linear regression model, the betas, beta naught plus beta naught, beta 1 until beta k is the population parameters, and they are unknown. So meaning that we do not know the value of beta naught until beta k once we have the data. So in the data, what we have is only the y values and also the x values. So we need to do an estimation method. We need to use estimation method, whereby it is called the ordinary least square, or OLS. So by using this estimation method, we will get the value of the intercept, which is the beta naught, and also the slope coefficient. So what is ordinary least square? So the least square methods produce the best fit or straight line through the sample data points that minimizes the sum of squares errors between the actual and the estimated values of y. So here y, if y minus y not, y minus y hat, this is the actual y, and this is the estimated y. So you have the actual y, you have the estimated y, you take the difference, and then this is the error, and then you square it, because the error will always have a positive and negative value. So you need to square it, and then you need to sum it, and then you need to minimize this summation. In this model, the y and x is the population data. So once you run the OLS on population data, what you have is the population parameter beta naught and also beta 1. But then if you do not have the population data, you need to take a sample from the population. So when you do the least square method, what you get is actually the sample regression line. And this line is also a straight line, whereby the equation is y hat equals to beta naught plus, equals to b naught plus b1x. So b naught and b1 comes from the sample data. Beta naught and beta 1 comes from the population data. So b naught and b1 is an estimator of beta naught and beta 1. So b naught is the estimate of beta naught. B1 is the estimate of beta 1. And here this y hat is called as the predicted y, or the estimated y. B naught is the estimated value of y when x is 0. So when x is 0, b1 times 0 is going to be 0, so you have the estimated y is just simply b0. And b1 here is the coefficient for x, and this is a straight line, so basically this is a plus bx, so this is the slope, and this measures the average change in y for each change of 1 unit in x.